These are the test results from the Fluoroelastomer Micropowder experiment. In this experiment, we used 170 mesh fluoroelastomer micropowder at 0, 10, and 20% above formula. The formulation is a 70 duro mineral-filled FKM, and the micropowder originated from the same formulation. This is heat-aged tensile strength 70 hours at 232 C. All of the samples were equal under this test. Heat-aged elongation was actually higher for the two samples that contained the micropowder. Heat-aged hardnesses were within 1 point. The samples were tested for oil-aged tensile strength 70 hours in API 5 gear oil. As you can see, the tensile strengths were equal in this case too. The oil-aged volume change under these conditions was essentially equal as well. Here are the compression set results. The 10% was equal to the control and the 20% only slightly higher. Die C-tear, the samples were essentially equal. Here are the dielectric results. Dielectric was once used as a measurement of even compound distribution in the early days of the rubber industry. If there was any difference in the dispersion or a filler dispersion or molecular dispersion within this polymer, it would show up in dielectric, and these dielectric tests are exactly equal. The lone difference in this experiment that was powder dependent was the Mooney viscosity. Mooney viscosity increased with higher powder loadings. This is what we see all the time when we're working with micropowders. And also what we saw in this experiment was slightly faster cure rate, which is correspondent with the higher viscosity, is also quite common. In physical properties, the samples containing the micropowder were equal to the control in every case. The compound viscosity increased with increased powder usage. This can be adjusted depending on the downstream processing needs.